Noche Cósmica.
Imagine the moment the first human foot pressed into Martian soil and nothing changed. No roar of crowds below in mission control. No headlines screaming across Earth. Just the soft hiss of a pressure suit's breathing, the crunch of rust-colored regolith beneath a boot, and then silence. That kind of silence, the kind that exists only on another world, where the atmosphere is so thin, less than 1% of Earth's air pressure, that sound itself seems to die before it fully forms. A whisper becomes an idea, the wind becomes a ghost. And in that weightlessness of noise, something shifts inside the human mind. Someone stands on a planet that is not their own, breathing recycled air from a machine strapped to their chest, and the question that has haunted us for centuries finally becomes flesh and physics. What if we never left? What if we stayed? That question, suspended now, not hypothetical but possible, hanging in the cold Martian atmosphere, is what we're going to walk through together over the hours ahead. Not quickly, not with urgency, but slowly, the way you might walk across a frozen landscape, noticing each step, each breath, the way the light changes. We're going to imagine, with precision and care and wonder, what it would mean if humans settled Mars not as visitors, but as permanent residents. If we built homes instead of camps, if our children were born there, if the red planet, in time, became as ordinary to us as continents and countries, if home could be redefined. And if you're drawn to these kinds of journeys, these slow explorations of what humans might become when we imagine ourselves into entirely new worlds, I'd invite you to subscribe here so that you can return to more of these mind-expanding stories about our possible futures among the stars. Now, picture it. Not the arrival yet. Picture instead the slow turning of a Martian dawn, hour by hour. The planet rotates much like Earth does, completing a spin every 24 hours and 39 minutes. Close enough that your body might almost adjust, might almost feel familiar, and yet just distant enough to keep you forever slightly unsettled. The sun rises in the east, as it does everywhere, but it rises smaller than it does on Earth. Mars is further from the sun, and the light that reaches it is dimmer, softer, the way afternoon on Earth might feel if the day were already beginning its descent toward dusk. There is no golden hour on Mars. There is instead a rust-colored hush. The dust that covers the Martian surface, that rust-red regolith, that gives the planet its color and its ancient, weathered character, begins to glow. Not brightly, never brightly, but with a kind of muted luminescence, the way sandstone cliffs catch early light. The iron oxide that stains every surface, every grain, every whisper of wind-blown soil seems to warm infinitesimally, and somewhere, if you were standing there, if you could feel it through your suit, you might sense it. The temperature hovers near freezing at the equator at midday. Everywhere else, especially as night falls, it plunges far below. -70 degrees Celsius at the poles, -100 or more when the dust settles and the thin atmosphere loses what little heat it has managed to absorb. The wind moves across that red landscape, but you would barely hear it. The thin air carries sound poorly. Martian wind moves at speeds that might rattle windows on Earth, and yet on Mars, if your helmet were open, which it could never be, the wind would touch you almost like a suggestion. Like the whisper of something half-remembered, it moves across dunes of rust and regolith, over ancient riverbeds that haven't flowed in billions of years, past rock formations carved by processes no one on Earth has witnessed for eons. The Valles Marineris carves a massive scar across the planet's face, a canyon system so large that the Grand Canyon could fit inside it dozens of times over. Olympus Mons rises in the west, a volcano so vast and so gently sloping that if you stood at its base, you wouldn't see the summit. You'd think you were walking on a gentle hill forever. This is the stage. This is the vastness that any human presence would have to contend with. Not a hostile environment in the way that space is hostile. Space doesn't care about you, doesn't hate you. Mars doesn't care either. But it is indifferent in a way that demands respect. The planet has been red and cold and empty for billions of years. The solar wind, that constant stream of charged particles flowing from the sun, has been stripping away what little atmosphere Mars once had, carrying it out into space, for longer than humans have existed. The planet has been bombarded by cosmic radiation, hard rays that would penetrate the thinnest of atmospheres, that would damage unshielded human DNA in hours. The poles are locked in ice. The dust is pervasive, fine as talcum powder, and would work its way into every seal, every joint, every mechanism. And yet humans have imagined living here, not for a day, not for a mission, but for generations, for centuries, for the permanent, irreversible rooting of our species on another world. What would that mean? What would we have to change? What would Mars have to change? And perhaps most deeply, what would we become? The question hangs there, in that thin, rust-colored dawn light, as real now as the ground itself. If you find yourself drawn to these kinds of questions, the ones that unfold across centuries and worlds, that ask not just what we might do, but who we might become, there's a particular kind of thinking worth cultivating. It asks us to imagine futures slowly and carefully, without rushing to conclusions, and to sit with the strange comfort of knowing that some answers won't arrive in our lifetime. When you listen to stories about deep space and deep time, about the possibility of humans living not as visitors but as inhabitants of another world, something shifts in how you hear the news of your own day. The ordinary becomes more precious. The technical becomes more poetic. If these journeys resonate with you, this slow unfurling of what Mars might mean for us, what it might ask of us, what we might learn about ourselves in the learning to live there, I'd invite you to subscribe. Each episode in this series ventures into a different threshold between the possible and the imagined. We explore the futures that sleep researchers, astrobiologists, engineers, and philosophers are actually thinking about, but we approach them the way you might approach a vast landscape at dusk, without hurry. There's no need to stay awake for these stories. They're designed to move at the pace of breath, to let your mind wander into the possibilities while your body settles into rest. Somewhere in that space between listening and sleeping, the deepest questions often find their answer. For now, though, let's return to that Martian dawn we began in, and let's ask something more urgent. What exactly are we returning to? And yet, before we follow those first human footsteps into that russet soil, we must pause and understand the world they would be stepping into. Mars, as it exists today, in this moment, is not a place that welcomes life as Earth knows it. It is, in almost every measurable way, a world fundamentally hostile to human existence. The atmosphere itself is the first shock. Earth's air, the invisible ocean we move through every moment of our lives without thinking, presses down on us with a weight of about 14.5 pounds per square inch. On Mars, that same atmospheric pressure drops to something barely measurable, less than 1% of what we experience here. It is as if you were to take the air of Earth and spread it across a planet only slightly smaller than our own, stretching it so thin that it becomes almost a memory of an atmosphere. The Martian sky, that salmon-pink hue that would greet any arriving human, is not actually pink because the air is thick and luminous. It is pink because dust particles in that gossamer-thin atmosphere scatter light in a particular way, and below that fragile veil lies something approaching a vacuum. Breathe without a spacesuit on Mars, and your blood would begin to boil. Not because of heat, though the surface can reach frigid temperatures that plunge to -230 degrees Fahrenheit at the poles, but because at such low pressure, the water in your body, which makes up more than 60% of what you are, would want to escape into that thin air as vapor. The body would swell, the lungs would collapse, death would come quickly and without mercy. Every human who would ever live on Mars would live behind barriers of metal and fabric and glass, never breathing the air that surrounds them, never truly touching that world directly. And then there is the radiation. Earth's atmosphere and magnetic field form an invisible shield around us, constantly deflecting and absorbing the cosmic rays and solar particles that stream toward our planet from the depths of space. Mars has no such shield. Its magnetic field died billions of years ago, and its thin atmosphere offers almost no protection. A human standing on the Martian surface receives a radiation dose roughly 200 times greater than what someone might experience on Earth. Over months and years, this accumulated exposure would damage DNA, increase cancer risk, affect the nervous system in ways we are still working to fully understand. The settlers would need to build not just homes but shelters, structures heavy enough and deep enough to block what the planet's own environment cannot. Many of the earliest habitats would be partially buried, covered in layers of Martian soil, regolith, as scientists call it, dust and rock that has lain undisturbed for millions of years, which would serve as radiation shielding, a blanket of ancient matter between the human body and the cosmic rain. The cold, too, would be a constant presence, a shape-shifting adversary that would demand endless vigilance. The average surface temperature on Mars hovers around -81 degrees Fahrenheit, though this varies dramatically with location and season. At the poles, in winter, thermometers would read numbers that strain comprehension, -225 degrees or colder. At such temperatures, carbon dioxide itself freezes from the air and falls as snow. Water, in these conditions, is not a liquid at all, but a rock, harder than steel. Machines designed on Earth would become brittle. Metal would shatter like glass. Every piece of equipment, every rover, every seal and joint in every structure would need to be engineered to function in an environment that seems designed to break things. Heating would be constant and necessary. Energy would be precious. The settlement would hum with the low, steady sound of machines working to keep the cold at bay. And where is water, that most precious of all substances for any human presence? The poles hold it, locked in permanent ice caps that combine carbon dioxide and water in frozen layers that have accumulated over eons. There is ice beneath the surface in many places, underground deposits of frozen water that lie dormant but accessible to those with the tools and patience to extract it. But water does not flow on Mars as it flows on Earth. It does not rain. Rivers died here billions of years ago. Lakes evaporated. The great network of liquid that made Mars, in some distant past, a warmer and wetter world, has retreated entirely into ice and into those buried frozen aquifers. For any human settlement, water would not be something found easily or abundantly. It would be something won from the ground through labor, through heat, through ingenuity. The soil itself presents another kind of puzzle. Martian regolith is not Earth soil. It has never hosted life. It contains no organic matter, no microbial communities, no complex ecosystem of decomposing matter that makes Earth soil dark and rich. Instead, the Martian surface is dominated by iron oxides and perchlorates, chemicals that are actually toxic to terrestrial plants. If you were to take Martian soil and attempt to grow Earth plants in it, they would fail. The ground beneath a human settlement would need to be transformed, treated, mixed with imported organic matter, fundamentally altered from its native state before anything green could grow there. Consider, then, what it would mean to choose permanence in such a place. To say not "we will visit," but "we will stay." We will build here, We will raise children here. We will make this home. It would require a transformation not of the planet alone, but of humanity itself. Every shelter would need to be a complete life support system. Every breath would need to be manufactured. Every drop of water would need to be fought for. The people who chose this would need to accept radical dependence on systems that could fail, on supplies that might not arrive, on the mercy of technology in an environment that offered none. This, then, is the threshold. This is what stands between the dream and the reality. Mars in its current state is beautiful in its starkness, magnificent in its desolation, but it is a place that demands complete and total human adaptation. Every permanent settlement would be, in essence, a small bubble of Earth existence, maintained against a planet fundamentally indifferent to human life. And yet, somehow, the question persists. If such an adaptation were possible, what would it transform? What would we become? Long before any human boot could press into that rust-colored dust, Mars had already been watched, studied, approached with mechanical patience by machines we built to see what lay waiting in that thin, cold atmosphere. And there is something profoundly moving, when you think about it, in how we learn to know Mars, not through presence, but through the careful, methodical eyes of our robots, each one a small bridge cast forward across the dark gulf of space, testing the way. The story begins in the summer of 1976, though perhaps it begins even earlier, in the hope that sent us looking. Two spacecraft named Viking descended through the Martian sky, and they became the first machines to touch down and send their voices back across millions of miles. Viking 1 and Viking 2 were not rovers. They were landers, stationary sentinels that would sit in one place and listen to the land around them. They carried cameras that could turn their gaze in every direction, instruments to taste the soil, sensors to read the wind. And when they came to rest in their chosen valleys, they began to whisper back stories of a world that was, by Earth standards, utterly hostile and yet utterly compelling. The soil was rusty with iron oxide. The sky was not blue, but butterscotch at midday, fading to deep purple at the horizon. The temperatures would plummet so far below freezing that carbon dioxide itself would sometimes fall as frost. And the wind was thin and whispering, almost apologetic in its reach, because Mars's atmosphere is so spare, so delicate, that even strong winds there would feel to us like a gentle breeze. What did we learn from Viking? We learned that Mars was real in a way it had never been before. Not a speculation, not an artistic imagination, not a mere point of light in the night sky. It was a place. It had weather. It had geology. And in those first images sent back, grainy by modern standards, precious beyond measure at the time, we could begin to imagine walking there. For years after Viking, Mars waited in a kind of suspended silence. The data from those first landers shaped decades of questions. Scientists studied the chemistry of that rust-red soil, the physics of that tenuous atmosphere, the evidence of water that must have flowed once, long ago, and the dream of human arrival, though it never left the minds of those who studied the red planet, began to seem almost impossibly distant. The technological leaps required were immense. The cost was staggering. For a time, it seemed Mars might remain forever in the realm of robotic servants. But the dream evolved, and with the turn toward the 1990s came a new kind of mission, a lighter step, a different kind of reaching. Pathfinder launched in 1996, and when it arrived at Mars a year later, it brought something revolutionary, a rover. Not just a camera on a fixed mount, but a small wheeled machine that could move across the landscape, could investigate, could explore. Sojourner was the name of this rover, and it was barely the size of a microwave oven, yet it represented a profound shift in how we approached Mars. No longer would we only look from where we landed. Now we could wander. We could examine rock formations up close. We could drive across ancient lake beds and wonder at the geology written in stone. There is something deeply intimate about the thought of a rover moving slowly across an alien landscape, its wheels finding purchase in Martian dust, its cameras turning to study each new vista. Pathfinder also brought us something else, those first transmissions of color images that made Mars feel almost tangible. Not some abstract point of study, but a place where sunlight fell in recognizable ways, where shadows cast by rocks told stories of a distant sun, where the horizon curved away into distance, just as it does on Earth. The early 2000s brought more rovers, each one more capable than the last. Spirit and Opportunity arrived in 2004, twin machines that would exceed their original missions by years, driving across the Martian surface with a kind of patient persistence that mirrors something fundamental in the human spirit, that drive to explore, to move forward, to see what lies around the next ridge. These rovers were larger, more durable, equipped with instruments that could drill into rocks, analyze their composition, search for signs of water's ancient presence. And they found what scientists had long suspected, evidence that Mars was once wetter, warmer, less hostile than it is today. They rolled through ancient riverbeds. They climbed mountains, they endured the Martian cold and the abrasive dust and the cosmic radiation in ways that no human could yet withstand unprotected. What was happening during these robotic decades? Something slower and deeper than mere data collection. We were learning the language of Mars. We were beginning to understand not just what it is, but how to live there. Every rover that drove across that rusty landscape, every instrument that measured temperature and radiation and soil chemistry, every camera image that revealed the planet's face, all of it was writing the instruction manual for human arrival. These machines were our scouts, our pathfinders in truth as well as name. They were testing the ground we would one day walk upon. And there is something almost tender in this relationship between the mechanical and the human, when you think about it long enough. The rovers themselves could never stay. Dust would accumulate on their solar panels, cold would crystallize their circuits, the relentless abrasion of Martian dust would wear them down. They were temporary, but the knowledge they gathered, the maps they made, the pathways they traced, these would endure. They would become the foundation upon which our permanent presence would rest. They were the first step that was not a human step. They were the careful preparation, the patient learning, the slow building of a bridge that would eventually allow us to cross from our blue world to the red one. By the time rovers like Curiosity arrived in 2012, the pattern was fully established. These machines were more than explorers. They were our representatives, our hands extended across the void. Curiosity carried a laser that could vaporize rock from up to 7 meters away. It had a drill that could bore into stone to access the material beneath the radiation-scarred surface. It carried a weather station. It had radiation detectors that would measure doses, that would give us the data we needed to understand what a human body would face on the Martian surface. Every tool bolted onto those rovers was a question being asked, answered, refined. How much radiation? Where is water? Can we find organic material? What is the soil really made of? What would we need to grow things here? How would we survive? The rovers themselves were always temporary, always finite, but they were building something permanent in us, a deepening knowledge, a widening certainty that yes, we could go there. Yes, we could survive there. Yes, we could learn to live there. And perhaps most importantly, they were teaching us the patient way of Mars itself, the slow, methodical approach required by its distance, its harshness, its unforgiving cold. There were no shortcuts to Mars. There was only the careful accumulation of knowledge, step by step, machine by patient machine. This is how we would learn to belong there. not through conquest or speed, but through humility, attention, and time. The descent begins not with drama, but with mathematics. A spacecraft carrying perhaps 6 people, or 12 or more, we cannot yet know, pierces the Martian atmosphere at speeds that would vaporize a meteor. The thin air, only about 1% as dense as Earth's atmosphere, offers little resistance, little comfort. The ship's heat shield glows. Instruments record what the crew cannot yet see. Temperature readings climbing, velocity vectors bending toward the red surface below. There is no roar of engines fighting against a thick atmosphere. Instead, the sound is almost intimate, a hiss, a whisper, the crackle of friction against thin molecules sliding past the hull. Minutes compress, the heat shield separates. Parachutes deploy into an atmosphere so gossamer thin that they pull gently rather than jolt. Retro rockets ignite. And here, in this final moment of mechanical descent, the ship slows to a walking pace, hovering perhaps 100 meters above the ancient rust-colored dust. Sensors scan the landing site, a location chosen months or years ago, robotically tested, analyzed from orbit. The ground below is strewn with boulders the size of rooms, with shallow ravines and the pocked scars of ancient impacts. It is not welcoming, it is simply there. The pilots guide the lander down. Their hands move across controls. Their breathing, though they may not notice it, has slowed. They have trained for this moment across thousands of hours in simulators, but simulation is a kind fiction. The weight of isolation, true, absolute isolation, has already begun to settle into the cabin. Any choice to land here is, in some psychological sense, a choice to accept that rescue may not be possible, that if something goes wrong, if engines fail to restart, if the ascent vehicle cannot reach orbit, then this landing site becomes a tomb. The crew knows this. They have accepted it. But acceptance and absence of fear are not the same thing. The landing struts compress. Dust rises in slow, delicate plumes, spreading outward in graceful arcs under reduced gravity. In Earth's museums and mission control centers, screens flicker with telemetry. But the crew experiences something that no camera, no data stream can fully convey. They experience silence. The engines cut. For perhaps the first time in their professional lives, the constant throb and hum of spacecraft systems, the pressure regulators, the life support fans, the thermal management pumps, falls away. What replaces it is not true silence. Martian wind, thin as it is, whispers against the hull. Equipment ticks and settles as it cools. But compared to the roar of launch, the vibration of cruise, the static of communication with Earth, it is an almost religious quiet. One crew member looks through a small window. The Martian landscape stretches away, subtle in color, not the vivid red of old paintings, but a dusky salmon tan, shadowed by terrain into suggestions of brown and gray. The sky above is not blue, but butterscotch in the afternoon light, fading toward a pale purple near the horizon. 2 small moons will rise later. For now, there is only the soft glow of late afternoon on an alien world, and the knowledge that they are standing on it. The psychological weight of true isolation is not something that strikes all at once, like a door slamming shut. It arrives in layers. The first layer is disorientation. The world outside is not Earth. The light is not Earth's light. The gravity is not Earth's gravity. Their bodies feel lighter, more buoyant. They can move more easily, leap higher. This can feel, initially, like freedom, like joy, even. The second layer arrives more slowly. It is the recognition that there is no crowd outside, no backup, no ready rescue. The nearest human beings are somewhere above the horizon, in orbit, in spacecraft, and the distance between them and the surface below is not merely geographical, but existential. The nearest human beings not in orbit are months away. Earth is months away. Home is months away. How do humans experience this kind of separation? Psychologists who study Antarctic researchers, submarine crews, astronauts on long-duration space flights have found that the reaction is highly individual. Some experience what might be called a kind of liberation, freedom from the constant ambient social pressure of human civilization, an opportunity to focus entirely on the work, on survival, on the profound and simple task of being present in an extraordinary moment. Others feel a creeping weight, a sense of unreality, as if they are watching their own lives from outside their bodies. Most people, most of the time, experience some combination of both. In this first cabin, on this first Martian landing, the crew begins the work of survival. They check systems. They review procedures. They communicate with orbit, with Earth, reporting their status. Their voices, when they speak, are steady, professional, trained, but underneath, they are experiencing something that cannot be trained away. They are the first humans to breathe recycled air on an alien world. They are the first humans to understand, in their bones and in their nervous systems, what it means to be irreversibly far from everything they evolved to understand as home. Outside, the Martian dusk approaches. The sun, smaller in the sky than it appears from Earth, descends toward the horizon. The temperature will drop. The wind will pick up slightly. Somewhere in the thin Martian night, water ice will form on the surface of rocks, condensing from the sparse moisture in the air. And inside the lander, in their suits still, in their harnesses still, the crew sits in the quiet and processes what they have done. They have crossed the threshold. They are, for the first time in human history, staying. The first thing the settlers would need to do, before any agriculture, before any journeys across the regolith, before almost anything else, would be to disappear underground. And this is not poetic exaggeration. It is the simple physics of survival on a world that, minute by minute, is trying to erase you. Mars, you see, has almost no magnetic field. Where Earth surrounds itself with an invisible shield generated by liquid iron churning in the deep core, Mars has a deadened heart. Its magnetosphere flickered out perhaps 3 billion years ago, and what remains is only scattered patches of ancient crustal magnetism, a fading memory written into the stone. This absence is catastrophic in a very particular way. Without that magnetic umbrella, every solar wind carries through unfiltered. Every cosmic ray that the sun doesn't immediately block finds a straight path down. The radiation environment at the Martian surface, on average, is perhaps 50 times more intense than what you experience on Earth, even if you worked outdoors your entire life. And this is not the quick, dramatic radiation of a reactor accident. It is constant. It is patient. It accumulates. So the earliest habitats would need to be fortresses, and the most practical fortress is the one you cannot see, because it uses the planet itself as its wall. Picture, if you allow it, a construction team descending into a natural lava tube. Mars has thousands of them, ancient tunnels carved by flowing basalt billions of years ago, some large enough to contain entire cities beneath their domed ceilings. Or imagine instead the slow excavation of a habitat into the regolith itself, the rust-colored dust and fractured rock of the Martian surface, dug down perhaps 4 or 5 meters, deep enough that the overburden of soil and stone becomes shield enough. Engineers would sink cylindrical modules, pressurized metal rings like sections of pipeline, into prepared trenches. The excavated regolith would be mounded back over the top, creating a gentle slope of Martian earth that covers the habitat completely. From the surface, there would be nothing to see except perhaps the faint outline of terrain, a subtle depression perhaps, or a mound barely distinguishable from the natural landscape. This is not the gleaming domed city of imaginative art, the transparent bubble where settlers watch the rust-colored desert under a butterscotch sky. That image, while it fires the imagination, would be lethal. Any dome exposed to open atmosphere would accumulate radiation so intensely that the people inside would need to spend much of their time in shielded chambers anyway. Why build a window to a world you cannot safely look at? Better instead to bury the critical spaces, the sleeping quarters, the medical facilities, the places where children would grow, and only venture to the surface when work demands it, and only then in protective gear, and only for limited durations. The buried habitats would have a peculiar geometry. They might be built in tiers, like the sections of a multi-story building but inverted, descending into the Martian crust rather than rising above it. The lowest levels would house the sleeping areas and the biological experiments, where developing systems for food production would begin. Above those, perhaps, would be the work areas, the labs where water could be extracted from the ice, where chemical and biological processes would slowly begin to transform Martian resources into tools and fuel. Near the surface, perhaps 1 or 2 levels down, would be the airlocks and the equipment rooms, where suits would be maintained and vehicles prepared for excursions. The walls of these habitats would likely be lined with more regolith, packed and settled in layers, mixed perhaps with water ice or with the structural fiber of imported materials. Regolith is not a friendly substance to live beside. It is fine, clinging, abrasive, and suffused with perchlorates that can damage your skin and lungs if you are careless. But it is also the most abundant building material available, and it is an excellent radiation shield. The heavier elements in the Martian soil, iron, sulfur, the various minerals that make it rust-colored, scatter charged particles and cosmic rays. The deeper you go, the safer you are. This is not philosophy. It is basic nuclear physics. And yet there would need to be some contact with the surface. Rover bays would need to open directly to the Martian air, chambers where vehicles could be maintained and loaded, where samples could be processed. These chambers might use a double lock system, an outer bay that maintains only partial pressure, a buffer zone between the thin Martian atmosphere outside and the comfortable 17 pounds per square inch of pressure inside the habitat where the settlers breathe. Workers moving between these zones would feel the slow transition, a pressure that climbs with each meter descended, a gentle reminder that they are moving from one world into another. The domes themselves, and there might indeed be some transparent or translucent structures, but smaller, more modest than the grand visions of science fiction, would likely be positioned not in the open but in sheltered locations, perhaps beneath overhanging cliffs or in the rims of impact craters, where natural topography provides additional shielding from solar wind and radiation. Any dome would be thick, perhaps made of multiple layers of plastic polymer interspersed with regolith, or constructed from a translucent material infused with elements heavier than carbon that scatter radiation. The light that reached the interior would be dim and reddened by the thin Martian atmosphere pressing against the dome's surface. Within these protected spaces, both the buried habitats and the shielded domes, the settlers would begin the slow work of establishing a human presence. The radiation dose inside these structures would still be higher than on Earth, perhaps 2 to 3 times the background radiation you receive at sea level, still far below the levels that would cause acute harm, but enough to require monitoring and care. The body would accumulate these insults across years, across decades. Children born in these shielded habitats would never know unfiltered sunlight, never step on the surface unprotected, at least not in the early generations. What does this do to the human spirit, this enforced caution, this hiding from the very world you have chosen to inhabit? We might wonder whether the initial pioneers, looking up at the domed ceiling or the packed regolith above their heads, might feel something like grief. They have come so far, crossed such enormous distance, overcome such difficulties, and yet they must tunnel deeper, must hide more, must accept that the Martian world outside, that vast, ancient, silent landscape that called them here, is fundamentally hostile to their existence. It is a theme that would repeat and deepen across generations. The planet offers nothing freely. Every resource must be extracted. Every atmosphere must be manufactured. Every bit of safety must be fought for and maintained. And yet, in these buried places, beneath the rust-colored shield of their adopted world, the first human communities on Mars would begin to take root. They would sleep in chambers carved from alien stone. They would eat food grown in manufactured soil. They would breathe air that no Martian atmosphere would ever provide. And in doing so, they would begin the long process of becoming Martian. In those first months of settlement, something quietly impossible begins to happen to the human body. The Martian day, or Sol, as the rovers first named it, stretches just 39 minutes longer than Earth's rotation, 24 hours and 39 minutes. It sounds like a small discrepancy, almost negligible when you think about it in the abstract, but that extra time seeps into everything, into the rhythm of work, into the architecture of rest, into the very way a person's biology tries to understand what morning means. Imagine waking in your habitat, the soft artificial lights gradually brightening to mimic dawn. Except dawn here comes later each day, by those 39 minutes. You rise and move through your routines, and at first, your body resists. Your circadian rhythm, that ancient internal clock shaped by 4 million years of Earth's precise 24-hour cycle, tries desperately to hold its course. You find yourself alert at the wrong times, drowsy when you should be working. This is not jet lag. Jet lag is a temporary drift across zones you could theoretically return to. This is something deeper. This is your entire biology being asked to drift away from the only timekeeper it has ever known. The early settlement schedule would have, almost certainly, attempted to maintain Earth time at first. The psychological comfort of knowing it was, say, Tuesday back home, the connection to mission control, the sense that you were still operating within a human framework. All of this would have pulled those first settlers toward keeping their watches and their routines aligned with a world they could no longer see. But slowly, almost without deciding to, the community would have begun to slip. A work shift would extend into what felt natural. A sleep cycle would deepen because the body was finally, genuinely tired. And within weeks or months, the settlement would find itself living on Martian time, not out of necessity, but out of something more compelling: biological honesty. Your circadian system is regulated primarily by light and darkness, but also by temperature, by feeding patterns, by the rhythm of work and rest that surrounds you. All of these can drift, though not without cost. When you first try to adopt a 24-hour, 39-minute cycle, your body resists with insomnia, with irritability, with a subtle sense of internal misalignment. But humans are remarkably adaptable creatures. Studies of people living in polar regions, where daylight patterns are radically distorted, show that while the adjustment is difficult, the body does eventually learn. It is not without strain. The melatonin system, that crucial regulator of sleep, takes weeks to recalibrate. Some early settlers would have experienced headaches, mood fluctuations, a general sense of being slightly out of phase with reality. But here is the curious part. Once the adjustment begins to take hold, there is a strange relief in it. Your body stops fighting against an impossible cycle and settles into a new rhythm that is, in its way, more natural for Mars than Earth. You sleep when the habitat dims, you work when it brightens, and the 39-minute extension means you have slightly more time in each Sol cycle to accomplish what needs doing. Some researchers, writing about this speculative future, wonder whether a generation born on Mars might find the old 24-hour cycle claustrophobic. What would it feel like to visit Earth and find time moving 40 minutes faster each day than your body expects? The settlement's clock would mark time in sols, probably numbered from the day of landing. Sol 1, Sol 43, Sol 812. The numbers accumulate in a way that feels divorced from Earth's calendar entirely, and this numeric distance becomes a psychological one as well. You are not living in your second month on Mars. You are living on a numbered sequence of days that belong entirely to this world. The hours within each sol might still be divided into the familiar 24-hour format, but the rhythms they governed would have shifted subtly, almost imperceptibly, toward Martian time. What happens to human culture when time itself begins to reshape? The settlement operates in the longer sol, and gradually the structure of the day shifts with it. Perhaps evening meals happen a bit later. Perhaps the work schedule stretches, permitting longer projects without artificial interruption. Perhaps people find they can focus deeper in the extended hours, that something about the rhythm suits the kind of work Mars requires, the careful, deliberate, methodical labor of maintaining life support systems, of cultivating water ice into usable reserves, of building slowly but with great intention. There is no rushing on Mars. Time moves at its own pace, and for people who have chosen to live here, that pace becomes, eventually, a comfort. Sleep itself might deepen on Mars. The slightly longer cycle could permit longer sleep periods without that abrupt morning alarm that Earth dwellers are accustomed to. Some circadian researchers speculate that humans might actually sleep better on a longer day-night cycle, that our modern 24-hour life is itself a kind of sleep deprivation that we have simply normalized. On Mars, without external pressure to maintain Earth's rhythm, the early settlers might discover sleep patterns that feel more restorative, more complete. And the children born into this rhythm, who have never known Earth time, would have no reference point for comparison. Their bodies would know only the Martian sol, and they would sleep and wake to its longer beat. Yet there is a subtle loss in this adaptation too, though it is difficult to articulate. Each time a human system drifts from its ancient origin point, something of connection is surrendered. The circadian rhythm is not merely a biological function. It is a link to the long history of human existence under Earth's sun, under the pressure of selection that shaped us. To slowly abandon that rhythm is to accept, at a cellular level, that you are becoming something other than what 4 million years of hominin evolution intended. It is not a tragedy, perhaps, but it is a kind of farewell that happens so gradually that you might never notice it occurring. You simply wake one sol and realize you are no longer the same creature your body was designed to be. This is the quiet revolution of the Martian sol, not violent, not sudden, but relentless in its slow remaking of human time. And yet, from the earliest blueprints of a permanent Mars settlement, another dream has always lived in the margin of that practical work, a dream that reaches forward across centuries, that asks a question most of the first settlers will never see answered. What if, one day, Mars became not just habitable, but alive? What if the rust-colored landscape itself could be transformed? This is where we step from engineering into something more speculative, more uncertain. The science of it is real enough, the physics and chemistry are sound, but the timeline stretches so far into the future that we must hold these ideas lightly, like a map of a country that may never quite become what we imagine. Still, the dreaming matters, because it shapes how humans might think about their long presence on that world. The fundamental challenge is Mars's atmosphere. Today, it is gossamer thin, barely 5% the pressure of Earth's at sea level, composed almost entirely of carbon dioxide, but without enough of it, without enough of anything, to hold heat or protect against radiation. To terraform Mars is, at its heart, to make that atmosphere thicker, to make it trap warmth, to make it breathable, eventually by human lungs without assistance. One path that scientists and dreamers have contemplated involves exploiting what Mars already has. Deep beneath the surface, beneath the ice caps at the poles, there exists frozen carbon dioxide, dry ice, locked away for billions of years. There is also water ice, and there is methane, and there are peroxides in the regolith. These are the chemical seeds of a thickened atmosphere, waiting. The idea unfolds something like this. Imagine releasing those greenhouse gases deliberately. Factories powered by energy from fusion reactors or vast solar arrays could mine the polar caps, vaporizing frozen carbon dioxide and releasing it into the thin Martian air. Dark dust, specially engineered or imported, could be sprinkled across the white ice at the poles, dust that absorbs more sunlight, that weakens the cap's grip on the frozen carbon locked within. As those caps shrink and sublimate, as the carbon dioxide escapes, the atmosphere would begin, ever so gradually, to thicken. With more atmospheric mass comes more heat retention. The greenhouse effect, the very mechanism we spend so much energy controlling on Earth, would be deliberately invoked on Mars. The planet would warm. Temperatures at the equator might rise by 20, 30, 40 degrees over centuries. Frozen water ice deeper in the ground would begin to melt. Underground aquifers, long dormant, might flow again, and as water vapor entered the atmosphere, it would amplify the warming further, another layer of greenhouse effect. This is not something that would happen in decades, or even centuries in the way we measure historical time. The most optimistic models, the ones that assume massive human effort and sustained commitment across hundreds of years, suggest that meaningful atmospheric thickening, enough to reduce pressure suits to simple respirators, to allow humans to walk outside without full life support, might take somewhere between 100 and 500 years. The more cautious estimates stretch toward 1,000 years or more. We are speaking of a transformation so slow that it makes the rise and fall of human civilizations look like the flutter of a candle. And it requires something almost unprecedented in human experience: sustained, multi-generational effort toward a goal that no individual alive will see completed. It demands a kind of faith in the future, a commitment that transcends nationalism, economics, and individual lifespans. Can humans maintain such focus? Can a Martian civilization, increasingly isolated and distinct from Earth, remain committed to a project initiated by ancestors they will know only through historical records? There are complications woven throughout. One concerns the very feasibility of warming Mars enough, even with aggressive terraforming. The planet is smaller than Earth, with weaker gravity. Its lack of a magnetic field means the solar wind continuously strips away atmospheric particles. Some scientists argue that even an artificially thickened atmosphere would slowly leak away into space, requiring perpetual maintenance or renewal. Others counter that with enough initial warming and thickening, a threshold might be crossed where Mars's own geological processes and hydrological cycles stabilize the atmosphere. The debate remains open, marked by question marks and provisional models. Another consideration is the chemistry itself. Mars's atmosphere would not, for centuries, resemble Earth's. It would remain primarily carbon dioxide, breathable for Earth humans only after extensive processing, only through mechanical extraction of oxygen from that CO2. The first generation born on Mars under an engineered greenhouse atmosphere would still breathe through masks, would still live in sealed habitats. It is perhaps only the fourth or fifth generation that might, theoretically, step outside beneath an alien pink sky and breathe, unassisted, an atmosphere wholly unlike anything Earth has ever held. And there exists a deeper philosophical complexity in the terraforming dream, one that the Martian settlers themselves would grapple with. If you transform Mars, if you warm it and water it and green its valleys, Are you creating a new world that is habitable for humans? Or are you erasing a world that is scientifically pristine, that preserves 4 billion years of Martian history unaltered by living processes? Are you committing an act of cosmic creation or cosmic colonization? These questions might seem abstract from the perspective of the first settlements, where the focus is on immediate survival and the maintenance of sealed domes. But for a civilization planning centuries ahead, for children born in underground habitats who will never return to Earth, the question of what Mars means, what it should become, what responsibility humans have to preserve or transform it, these become central to identity, to culture, to the stories a Martian society tells itself about its own purpose. For now, the terraform remains theoretical, a possibility held in the realm of scientific speculation and thought experiment. The early settlements on Mars will not engage in intentional atmospheric engineering. They will tend their domes, manage their radiation exposure, drink their melted ice water, and watch the thin sky. But somewhere in their planning documents, in their long-term visions, this dream persists. The dream that one day, if humans remain, if they commit to the patient work of centuries, Mars itself might be remade. Not quickly, not certainly, but perhaps. Yet as the machines dig deeper, as the settlements expand, and the first children take their hesitant steps across the rust-colored soil, a question begins to haunt every planning session, every engineering blueprint, every conversation whispered in pressurized corridors. Where will the water come from? Because without water, Mars remains a tomb. With it, the red planet becomes something else entirely, something that could sustain not just survival, but the slow, patient accumulation of generations. And the answer, it turns out, has been waiting in the Martian geology all along, locked away in forms so subtle that the earliest explorers nearly missed it. Deep beneath the equatorial plains, where the dust settles and time moves in geological epochs, water exists in the form of ice. Not glittering glaciers visible from orbit, but diffuse, scattered, ground-level permafrost mixed with the regolith itself, ice that extends downward into a kind of frozen aquifer that spans vast portions of the planet. At the poles, the situation becomes even more pronounced. The North Polar ice cap, it turns out, contains not just frozen carbon dioxide as once believed, but substantial reserves of water ice, layered beneath the dry ice with a kind of patient permanence. Some estimates suggest there are more water molecules locked in the Martian poles than in all the Great Lakes combined, waiting for the technology and the human need to extract them. But water on Mars exists in a state of extraordinary subtlety. It is not simply waiting on the surface to be collected. It is woven into the soil itself, bound at the molecular level, requiring heat and skill and patient engineering to coax forth. The process begins with extraction, a straightforward concept that unfolds into considerable complexity. A settler might drill into the regolith, heating the surrounding material to sublime the ice directly into vapor, which is then captured and cooled back into liquid. Or they might scoop the ice-rich soil itself and bring it into a pressurized facility, where the slow warming occurs in controlled darkness, the frost collecting on cold plates like the morning condensation on a window in an old, familiar world. In the earliest settlements, this water becomes sacred in a way that only those who have lived without abundance can truly comprehend. Each liter extracted is accounted for, rationed, used with an attention that people in water-rich nations have largely forgotten. A settler drinks with gratitude. They bathe in the faintest trickle of reused water. Every drop that has already served one purpose is carefully routed toward another. And yet, beneath this scarcity lies an extraordinary fact. The process that extracts water from the Martian soil produces something else, a byproduct that becomes as essential as the water itself. Hydrogen, the lightest element, the most abundant substance in the universe, waiting to be liberated from those H2O molecules. And hydrogen, combined with the carbon dioxide that fills the thin Martian atmosphere, becomes fuel through a process called the Sabatier reaction, a chemistry that has been understood for more than a century, but never before applied on an alien world. The hydrogen burns with CO2 to produce methane and water. The water is used for drinking and sustenance. The methane becomes rocket fuel for the return journey, or for the vehicles that carry settlers across the vast planetary distances. The system begins to fold back upon itself in a way that feels almost orchestral. Extraction creates fuel. Fuel powers movement. Movement enables the discovery of more ice, more water, more possibility. Think for a moment about what this means for the early farms, the delicate pressure domes where the first green things grow in Martian soil. Water here is not merely a resource to be efficiently allocated, it is the foundation upon which the entire agricultural dream rests. The regolith beneath the domes has been enriched with organic material brought from Earth or created through careful decomposition of waste, but without water, it remains inert, lifeless dust. When water is introduced, when the soil is given that essential molecule, something ancient awakens. Seeds germinate, roots extend. Chlorophyll captures the dim Martian sunlight and transforms it into energy. Within months, the first shoots of green push upward, a color that has not existed on Mars for billions of years, or perhaps has never existed at all, save in this moment, in this human-built sanctuary. The farmers of Mars will develop a relationship with water fundamentally different from that of their ancestors on Earth. They will know its weight, its rarity, its absolute indispensability. They will recycle it obsessively. Every drop of human sweat will be collected. Every bit of condensation from the air will be harvested. The water that nourishes the crops will be carefully filtered and returned to the system after harvest. Nothing will be wasted, because nothing can be wasted. And in this obsessive attention to water, perhaps there emerges a kind of wisdom, a recognition of the truth that earth-bound humanity has largely ignored, that water is not an abundant resource to be used carelessly, but a precious library of possibility itself. As the generations progress and the settlements grow from small research stations into sprawling communities, the question of water becomes not simpler but more nuanced. The northern polar region, with its vast stores of accessible ice, might become a center of activity, a water-rich hub that supports larger populations, more agriculture, more expansion. Drilling operations would sink deeper, accessing not just surface-level frost, but the vast subsurface reservoirs that remain frozen in the permafrost. Or perhaps the most ambitious settlements will locate themselves not at the poles but at the equator, where solar panels function most efficiently, and the landscape offers better opportunities for expansion, accepting the harder work of extraction from more diffuse underground reserves. There is something deeply reassuring in the knowledge that water exists on Mars at all. In the first decades of human presence, when every mission was uncertain and the possibility of failure felt perpetually close, the existence of water made the dream seem less like fantasy and more like a genuine frontier. It transformed Mars from an object of study into a potential home, because wherever water exists, wherever it can be extracted and used, there is the possibility of permanence. There is the scaffold upon which a civilization might be built. And yet, in the quiet hours when a settler stands inside a pressurized dome and watches the ice sublimate in a heating chamber, observing those precious molecules transform from solid to vapor to liquid once more, there is perhaps a meditation on transformation itself. The water on Mars is not alive, not in any sense that Earth recognizes, but it is mobile, present, available, a fundamental building block being remade again and again into forms that serve human need. In this gentle alchemy of extraction and use and recycling, perhaps there is a kind of music, quiet and patient, that plays through all the systems of a world being slowly, deliberately awakened to human presence. Within a decade of the first landing, the first child draws breath inside a Martian dome. The moment happens quietly, almost inevitably, a new person whose first breath tastes recycled air, filtered through regolith dust and membrane walls. This is the threshold where Mars shifts from outpost to world, where biology itself begins its slow, irreversible conversation with a planet that weighs less than half as much as the one that shaped humanity for 200,000 years. The child's skeleton develops in gravity that is only 38% of Earth's pull. This is not metaphorical. It is written into bone density from the beginning. The forces that craft our frame, the constant downward press against muscle and ligament, and the mineral scaffolding beneath, are simply quieter here. The bones grow, but they grow differently. They are lighter. They are, in a real sense, optimized for a world that asks less of them. A child born under Earth gravity would feel heavy on Mars, pressed down by invisible chains. But a child born here has never known those chains. For them, this lightness is the world. The first Martian child is taller than Earth children of the same age. Not dramatically, perhaps an inch or two across the first decade, but measurably. The spine extends with less load bearing down. The legs stretch into slightly longer proportions. There is no hurry to this. The body simply unfolds along different architectural lines, as if following a blueprint that Mars itself has suggested. The head sits a fraction higher on the shoulders. The gait, when they learn to walk, has a different cadence, more springy, less heavy. They move through the domes as if they belong to the air itself. But there is something else, something that runs deeper than the visible frame. The cardiovascular system, too, begins to drift. A human heart pumping blood on Earth works against the constant downward pull of gravity, fighting to push fluid upward to the brain, struggling with every beat to maintain pressure in the vessels and capillaries. On Mars, this burden eases. The heart does not need to work as hard. Over generations, what happens? Does the heart grow smaller, more efficient? Do the blood vessels that once needed thick walls to resist constant pressure become thinner, more delicate? No one yet knows. These are questions written in the body of a child who is still learning to run. The bone density issue surfaces first in the clinical language of the medical staff. They measure it obsessively, X-rays and scans and comparisons to Earth baselines that now seem almost abstract, like comparing a fish to a bird. The children's bones are 20, 30, sometimes 40% less dense than what textbooks call healthy. In Earth gravity, these bones would break easily. They would be brittle. But here on Mars where everything weighs less, they are perfectly adequate. More than adequate. They are exactly right. The question that haunts the doctors is not whether the bones are strong enough for Mars. Clearly they are. But what happens if a Martian child ever tried to live on Earth? The answer, almost certainly, is that they could not. Not without a lifetime of rehabilitation, not without prosthetics and support systems. A child born on Mars could never go home to Earth. Within 2 generations, the biological drift accelerates. The second generation, children born to parents who were themselves born on Mars, shows even more pronounced differences. Taller, longer-limbed, lighter-boned. Some of the medical staff begin to wonder aloud, softly and carefully, whether this is still human variation or the beginning of something else. A subspecies, perhaps. Homo martianus. They do not use that term in official reports, but it exists in quiet conversations in the HAB module kitchens late at night. Muscle adaptation follows. Mars children are less muscular, not because they are weak, they are quite capable for their environment, but because the lighter gravity simply does not demand the same muscle mass. A child on Earth might need strong legs to jump their own height. A child on Mars might jump twice their height with barely any effort. Why would their legs grow massive? The body, always an elegant optimizer, scales itself to its world. Over years, the musculature becomes more efficient, more refined. There is a kind of grace to it, though Earth observers might call it fragility. The nervous system adapts too, though this is harder to measure. The vestibular system, the inner ear mechanism that helps humans balance and orient themselves in gravity, is recalibrating. Children born on Mars have slightly different proprioceptive feedback, a different sense of where their bodies are in space. They move with what Earth visitors sometimes describe as fluidity or dreaminess, as if they are responding to gravity vectors that the visitors cannot feel. The neural architecture is still human, still recognizably human, but it is wired for a different world. And then there are the questions that open even further when we ask them carefully. What about the eyes, which developed in Earth's gravity over millions of years of evolution? Do they change? What about the inner ear, the organs, packed and arranged as they are by gravitational force during fetal development? Do they shift positions slightly in the womb on Mars? One Martian obstetrician has begun keeping detailed notes about organ positioning in ultrasounds, comparing them to Earth data, seeing small deviations. Nothing dramatic, nothing harmful, just different. By the time the second Martian generation reaches adolescence, there is something profoundly visible in the way they inhabit their world. They are adapted, visibly, measurably adapted. An Earth visitor looking at a 17-year-old Martian girl sees something that is close enough to human to be uncanny, close enough to recognize, but subtly foreign. The proportions are off in ways that are hard to articulate. The way she moves through a room, the length of her limbs, the way her hair seems to float slightly even when she is standing still, as if it is accustomed to moving in lighter air. A mirror of humanity, but one that has begun to reflect something new. The families themselves start to notice it in small ways that accumulate into something larger. A mother born on Earth, visiting from the first generation, watches her child, someone born on Mars, and feels a strange distance that was not there before. The child is hers, still undeniably her child, but there is something in the bodily knowledge that has diverged. The way the child moves through space is not the way the mother moves. The effort required is different. The relationship to gravity is different. They are, in some essential way, adapted to different worlds. Some of the Martian parents begin to wonder, in the careful language of people who are living through biological history and are aware of it, whether they have become ancestors, whether their children are the first of a new kind, not a different species, not yet, perhaps not ever, but adapted beings, Martian beings. This thought comes with a kind of awe, and underneath it, sometimes, a whisper of something else, separation, divergence. The moment when one branch of humanity begins to walk a different path than the other. The medical teams track it all with meticulous care, running tests and comparisons, documenting the subtle ways that bones and muscles and organs are reshaping themselves across generations. They flag the bone density concerns, though fewer and fewer people find them concerning as time passes, since the Martian children are demonstrably healthy and strong in their own world. They measure muscle mass and compare it to Earth norms that are becoming increasingly irrelevant. They ask the children how they feel, what their lives are like, whether they think of themselves as human or as something else entirely. The children, in their simple wisdom, often say that they think of themselves as Martian, and that it seems strange that this would be a question at all. And yet, beneath those layered habitats, in pressurized chambers buried meters below the regolith, something altogether different begins to unfold, something that calls to a very ancient part of human memory. The first Martian farmers, if we can call them that, would have stood before seeds in soil that had never known rain, never felt the warmth of a living sun filtered through a thick protective sky. They would have faced a question that reaches back to the moment our ancestors first learned to stop hunting and start planting. How do you make the desert bloom? The Martian greenhouses, imagined now by agronomists and engineers, would not resemble the glass structures we know on Earth. They would be domes or rectangular chambers of reinforced polymers and regolith-covered walls, sealed against the thin, poisonous atmosphere outside. The pressure within would be carefully maintained, the temperature held in a narrow band, the humidity managed as precisely as the oxygen itself. And yet inside would be a green world, rows of hydroponic towers perhaps, or carefully engineered soil beds, where nutrients would be delivered drop by drop, light engineered through full-spectrum LEDs, or perhaps, eventually, funneled in through expensive optical systems that caught and concentrated the rusty Martian sunlight. It is a strange inversion of Earth's farmland, where the sky itself becomes an engineered thing, built rather than inherited. The soil beneath these domes would itself be a creation. Raw Martian regolith, that fine rust-colored dust collected from the landscape, would not be fertile at first. It lacks the organic matter, the bacterial communities, the mycorrhizal networks that make Earth soil alive. But it could be transformed. Scientists have already begun experiments with simulated Martian soil, enriching it with organic compounds, inoculating it with hardy bacteria and fungi from Earth's most extreme environments. Organisms that thrive in Antarctic soil, in caves untouched by sunlight, in the acidic, mineral-poor places where life persists anyway. Slowly, over seasons measured in Martian sols rather than Earth days, the soil would begin to harbor microbial life, and as it did, it would begin, almost imperceptibly, to become fertile. What would grow first? Potatoes, perhaps. The crop that has already traveled so far from its Andean origins, that has fed human populations in climates as harsh as any on Earth, and that, according to experiments NASA has conducted, responds well to the unique conditions of simulated Martian agriculture. Or perhaps leafy greens, lettuce, spinach, kale, plants that grow quickly, demand less energy, provide vital nutrients. The earliest Martian settlers would not have had the luxury of diverse, abundant harvest. Their crops would have been carefully selected for efficiency, for their ability to produce maximum calories and maximum nutrition with minimum water, minimum light, minimum space. Every harvest would have been counted. Every failed seed would have been a small grief. But as the years passed, and as populations grew, so would the agricultural diversity. Beans and legumes to fix nitrogen into the engineered soil, tomatoes and peppers, not for survival but for something more subtle, for the taste of home, for the memory of earth gardens. Fruit trees, eventually, growing slowly in the reduced gravity, their roots spreading through soil that still held the dust of another world. And with them would come something that many of the engineers and planners do not speak of openly, though it is one of the most essential nutrients for the human spirit, the smell of green, growing things. That smell, the complex compound of chlorophyll and volatile organic compounds released by healthy plants, the loamy scent of soil rich with organic matter and microbial life, would become a profound sensory anchor in the lives of Martian settlers. Earthborn colonists might weep the first time they stepped into a greenhouse and encountered it again. For those born on Mars, it would be one of their first and most profound connections to a world they had never seen. A place their parents spoke of in stories and images, but which existed for them primarily as scent, as taste, as the green light filtering through the domes above their heads. The efficiency of these food systems would need to be extraordinary. Early estimates suggest that to feed a single person on Mars for a year would require careful cultivation of perhaps 30 to 50 square meters of growing space, depending on the crop mix and the technological sophistication of the greenhouse. That is not large, a modest garden by Earth standards, and yet multiplied across a settlement of hundreds, or eventually thousands, it would represent a vast network of green chambers humming quietly beneath the red dust. The electrical demand alone would be staggering. Solar panels on the surface, catching the thin Martian sunlight, supplemented by power generated from nuclear reactors or fuel cells, constantly feeding energy into systems that replicated the conditions of Earth. Yet there is an elegance to this arrangement that deserves contemplation. The settlers would breathe out carbon dioxide, and the plants would breathe it in. The plants would release oxygen, and the settlers would breathe in. In the most literal sense, a sealed Martian habitat becomes a closed loop, a miniature biosphere. The agricultural systems would not merely produce food, they would be part of the life support itself. Every tomato, every potato, every leaf of lettuce grown in that rusty soil would be an act of survival and also an act of poetry, a gesture toward permanence, a quiet statement that here, on a dead world, life persists, it adapts, it takes root. The scientists and engineers planning these systems think carefully about what they call resilience. What happens if one greenhouse fails? What if disease strikes the crops? What if the carefully balanced systems collapse? And so the agricultural networks would need to be redundant, distributed, diverse. Multiple locations, multiple crop types, backup systems upon backup systems. And yet, despite all this planning, all this engineering, the settlers would know, as all farmers know, that they remain fundamentally dependent on nature's cooperation. The thin Martian air might fail them, the water might freeze in unexpected ways, a crop might fail for reasons no one predicted, and so they would farm with caution and with hope, the way our ancestors farmed on Earth's uncertain landscape, but in this case, tending their green domes under the watchful presence of a cold, airless sky, knowing that every seed they coax into growth is a small miracle, a quiet statement of faith in the future they are building. And as these settlements grew roots, generation after generation learning the rhythms of a world not born from Earth, something unexpected would begin to bloom. Not in the soil of those engineered greenhouses, though life would flourish there too, but in the quiet spaces between people, in the stories they would tell, in the ceremonies they would create, in the very way they marked time itself. The first and perhaps most intimate shift would come to something so fundamental that it shapes every waking hour: the calendar. Earth's day, that steady 24-hour pulse we know in our bones, would slowly become a ghost rhythm. Mars, you see, rotates more slowly. A Martian day, a sol, as explorers have already begun to call it, stretches to 24 hours and 39 minutes. A small difference, negligible to the human eye, but lived day after day, week after week, season after season, that 39 minutes would become a small current pulling at everything. Clocks would tick differently, sleep patterns would drift, and over generations, the cognitive rhythm of Martian people would begin to match the planet beneath their feet, rather than the distant one above. New words would emerge for this. The early settlers might call it the soul drift, or something softer still, perhaps in whatever hybrid languages would evolve in those domes, something that captured both the physical sensation and the philosophical meaning of learning to live in Martian time. There would be calendars, yes, but they would mark not the long Earth year of 365 days, but Mars's longer journey around the Sun, nearly 687 days. Could you imagine? A year that felt stretched, luxurious, giving more time for seasons to fully unfold, more time for a civilization to dream before the year turned again. and holidays would crystallize around this new planetary rhythm. Not birthdays marked by solar position, perhaps, but dates that spoke to the actual experience of living there. Landing day would matter, yes, the anniversary of the first human feet touching the surface, but it would gradually share ceremonial weight with other markers. The Sol, when dust storms reached their peak, the moment when the frost at the poles deepened into its annual minimum, the day when light from the distant sun, that small pale disk in the pink sky, reached its most oblique angle. There might be a festival marking the passage of one full Martian year, a moment of genuine cyclical completion on the world itself. Some scholars of human culture might softly wonder whether such a day would grow to rival the old Earth year in its emotional significance, whether children born on Mars would feel, at their core, that they had lived one true year when they had completed one Martian orbit, regardless of how many Earth years had passed. The psychology of place, after all, shapes how we measure our lives. The two moons above, Phobos and Deimos, would inevitably become woven into the cultural fabric as well. Their movements, so different from our familiar single moon, would create their own mythology. Phobos, the larger one, rushing across the sky from west to east, completing its orbit in less than a day. Deimos, more distant, taking 3 days to cross the heavens. Could an artist not be moved by such strange celestial choreography? The compositions they might create, watching two moons trace their separate paths above a landscape of rust and rock. Poetry might emerge that tracked Phobos's frantic journey, that lamented Deimos's leisurely arc. New constellations, mapped not from Earth but from this new vantage point, would acquire names and stories, and the sky itself would become a source of constant visual inspiration. That salmon pink hue, caused by iron oxide suspended in the thin atmosphere, would shape aesthetic sensibilities in ways we can barely imagine now. Consider how deeply the color of Earth's sky, that particular blue, has saturated human art, human language, human longing. Painters on Mars would work with a palette transformed. The sunset there produces colors Earth has never worn, a blue-gray twilight spreading from where the sun descends, the sky darkening to a purple at the zenith. Musicians might compose pieces attempting to capture the tonal quality of that light, the particular melancholy or peace it inspires. These things, repeated daily, would seep into the culture's very bones. New languages would likely emerge too, or at least the dialects of Earth languages would begin to drift and diverge, as all languages do when communities become isolated. New words would be needed for experiences unique to Mars. What would you call the particular sensation of standing in full sunlight yet feeling no warmth? How would you describe the red dust that gets into everything, that colors your skin and your clothes and your breath? Early speakers might blend English and Mandarin and Spanish and whatever other languages the first settlers brought with them, but over generations, something new would coalesce. A Martian dialect, perhaps, or several, if the settlements grew distant enough from one another. The visual arts would transform in ways both practical and profound. Architecture on Mars would become a kind of art form simply by necessity. The sculpted domes and tunnels would gradually accumulate aesthetic intention alongside their survival purpose. But beyond function, there would be murals painted on the interior walls of habitats, sculpture crafted from Martian stone, installations responding to that alien light. Some artists born on Mars would never set foot on Earth. They would never know Earth's forests, Earth's oceans, Earth's sky. What would their art look like, having only Mars as reference? What memories would they try to capture, knowing them only through family stories and archived images? Music would shift too. The instruments brought from Earth might be joined by instruments created for this new world. The acoustic properties of pressurized domes are different from concert halls. The materials available are different. A musician working in those chambers might develop new styles, new tuning systems perhaps, and the subjects of songs, the themes of celebration or mourning, would gradually become Martian rather than Earth-borrowed. Love songs might reference ice at the poles. Lullabies might invoke the swift passage of Phobos. Work songs might mark the rhythm of greenhouse tending or mining, or the daily maintenance that keeps a Martian settlement alive. Rituals would form too, those small ceremonial acts that bind communities together. Perhaps a greeting gesture that took into account the lower gravity, a particular way of gesturing or moving that felt natural in Martian air, a way of marking milestones that drew meaning from the landscape, that incorporated Martian stone or ice or light. Families might develop their own rituals, passed down through generations, that made meaning out of their unique situation. What would a Martian wedding ceremony look like? A funeral? These moments would gradually acquire their own logic, their own beauty, drawn from the reality of living on another world. And underlying all of this would be something deeper still, a slow, accumulating sense of cultural identity distinct from Earth. The older generations, those who remembered blue skies and ocean horizons, might sometimes feel the pull of Earth nostalgia, but children born on Mars would know only the pink sky, only the gravity that held them with a different touch, only the faces of others who shared this specific reality. They would have stories, yes. Family histories and educational archives would keep Earth present. But Earth would gradually seem like a distant homeland, a place their ancestors came from, rather than the obvious center of human existence. Mars would be home, and slowly, over generations, that identity would solidify into something that could only be called Martian culture, not a copy of Earth brought elsewhere, but something genuinely new, shaped by a world and a sky that had never belonged to humans before. Within a few generations, the mathematics of survival on Mars would reshape governance itself. A colony of 3,000 souls, or even 10,000, cannot afford the friction of distant bureaucracy. Every decision cascades. The person who manages water allocation sits in the same cafeteria, breathes the same recycled air, watches the children of those they've disappointed move through school corridors. Democracy, in such a place, transforms into something more intimate and more fragile. History whispers this lesson through the faint voices of isolated outposts that have endured on Earth. Consider the Antarctic research stations, where 200 people spend a winter night that lasts 6 months, physically separated from the rest of humanity by impassable ice and howling darkness. The hierarchies there are flatter than in most organizations. The station commander must work alongside the mechanic, the cook, the geologist. A rupture in social trust becomes a rupture in survival. There is no option to simply resign and leave, no other restaurant, no sidewalk to walk down to clear your head. You finish your shift. You eat dinner with the person who frustrated you. You sleep in a bunk that might be 30 feet from theirs. Mars would demand something even more profound. An Antarctic station exists in perpetuity, knowing that relief ships will arrive, that resupply is certain, that a person who becomes truly dysfunctional can be evacuated or replaced. Early Martian settlements would operate under no such promise. The first crews would be selected with almost forensic attention to psychology and social compatibility, not merely technical skill. Nations and private entities would understand, with crystalline clarity, that a person's ability to manage conflict, to listen, to contribute even when exhausted or grieving, becomes as vital a specification as their engineering degree or medical training. Imagine the governance structures that would emerge. Consensus building would likely dominate the earliest decades, not from ideological commitment, but from practical necessity. Major decisions about resource allocation, settlement expansion, maintenance priorities, these would demand broad buy-in, because the cost of resentment, of a worker who moves with half attention or shares frustration through whispered conversations is genuinely dangerous. A saboteur on Mars, even an unconscious one, could threaten the entire system. Over time, as populations grew and cities became less face-to-face, traditional forms of representation might slowly reappear. Districts, councils, elected officials. Yet even then, they would carry traces of that early intimacy. A Mars city of 50,000, after all, is still small by Earth standards. Networks of kinship, of worked shared difficulties, would create invisible but powerful currents beneath formal structures. The child of a water engineer and the descendant of a dome builder might find their life paths different, not through corruption exactly, but through the simple weight of family memory and alliance. There is something to examine in how isolation shapes the bonds between people. When you are truly vulnerable together, when the oxygen comes from the same system that keeps everyone alive, when the farm that feeds you is tended by your neighbor's hands and your child's teacher, the social contract becomes almost sacred. Historians studying the early Jesuit missions in remote regions, or the first European settlements in frontier territories, have noted that extreme hardship either dissolves communities utterly or fuses them into something remarkably cohesive. On Mars, dissolution would mean extinction. That clarity would focus every decision. The question of who decides becomes inseparable from the question of who stays. Imagine a settlement where housing is not purchased but allocated based on role and family size, where moving away is not an option, where your child might inherit not your wealth but your responsibility within a system. Some would thrive in such a structure, finding belonging and purpose. Others would chafe against it. The psychological tolls of permanence, of knowing that your choices are constrained not by law primarily, but by survival itself, would create a distinct kind of community consciousness. Conflicts would arise, certainly. Personal grudges, philosophical disagreements, disputes over resource distribution. How would a Martian settlement handle serious crime? Exile to Earth is a death sentence for all but the earliest, healthiest arrivals. Imprisonment in domes where everyone lives in proximity seems nightmarish. Some form of restorative justice, of forced reconciliation and reintegration, might become dominant out of pure pragmatism. You cannot afford to have an alienated population. You cannot afford to expend resources on permanent punishment. Everyone must eventually be brought back into the working system, made to feel part of the enterprise again. The bonds forged in such pressure would be unlike those in ordinary human communities. There would be a depth to them, earned through shared sacrifice and mutual dependence that is rarely demanded on Earth. But there would also be a brittleness, a potential for hurt, to cut deeper, because the stakes are so high. The person you quarrel with cannot leave town. The friend you disappoint cannot easily find a new social circle. The community you're part of is not replaceable. That knowledge, held in the body of every settler, would make them attentive to one another in ways that feel almost hyper-aware by Earth standards. What emerges from this is not a utopia, but something that might be quieter and more conscious than most human settlements. Not immune to conflict, but shaped by it, pressed and refined by the constant awareness that the community's survival and your own are bound together so completely that they have become the same thing. In that recognition lies both profound connection and the weight of permanent accountability. By the time the third generation of Martians is old enough to ask questions about their origins, something subtle but irreversible has begun to shift in the human story. The children born under the rust-colored sky, who have never felt Earth's gravity fully, who learn to walk in the patient, bounding stride that only 38% Earth normal gravity permits. These young people carry within them a fundamental reorientation of identity that no amount of Earth history teaching can entirely undo. Their bones are longer, their frames more attenuated, their hearts pumping a slightly different song through their bodies than their ancestors' hearts ever did. But the change goes deeper than biology. It lives in how they perceive home, and time, and belonging. Consider what happens when a 9-year-old child, born in Olympus Station or in one of the newer settlements spreading across the Tharsis Highlands, asks their parent a question that would have been unthinkable to earlier generations. Why would anyone ever want to leave Mars? For this child, Mars is not a destination arrived at after a 9-month journey through darkness. It is the only world they have ever known. Earth exists for them as a story, a blue marble glimpsed through high-resolution telescopes, a place where their great-grandparents came from, the way an American child might think of the ancestral villages their grandparents left behind. But Earth for these children carries an added strangeness. It is heavier, its sky is achingly blue instead of butterscotch and mauve. People there live so clustered together, breathing air so thick it seems almost like drowning. The notion of standing beneath a full sky filled with clouds, of rain actually falling from above, strikes them as exotic, almost incomprehensible. Developmental psychology suggests that our earliest environment shapes not just our memories, but our baseline sense of what is normal, what feels right, what constitutes home. The limbic system, that ancient part of the brain that processes emotion and memory, becomes calibrated to the sensory world of our childhood. For the first generation born on Mars, their developmental baseline is the soft salmon light filtering through reinforced dome walls, the particular quality of wind howling through canyon systems, the silence of a world with no birds, the gravity that makes each movement a slower, more deliberate gesture. They have never known the weight of 300 pounds pressing down on a 100-pound body. They have never experienced the muscular fatigue of fighting against Earth's pull. The Martian environment is not something they have to adapt to. It is the mold into which they have grown. This does not mean they would be strangers to Earth. Advanced genetic therapies and bone density treatments developed over decades of Martian habitation might allow a young Martian-born person to visit their ancestral world for brief periods without catastrophic physiological collapse. They could make the journey, could stand beneath the blue sky their ancestors knew, could breathe the thick air and feel the crushing weight of gravity. Some would do it, perhaps as a kind of coming-of-age rite, a pilgrimage to the homeland of the species. But returning would feel like coming home, in a way that visiting Earth never could. The gravitational heaviness would seem wrong, tiring, oppressive. The perpetually clouded sky would feel confining rather than comforting, and the constant hum of other humans, the traffic, the chaos of crowds, the artificial light and noise of Earth cities would feel overwhelming to someone raised in the quiet, controlled environments of Martian habitats. This psychological reorientation carries profound implications for identity. We know from migration history, from the study of diaspora communities and the formation of national identities, that within 2 or 3 generations, a displaced population begins to see the place of exile or settlement as their true home. The Martian-born would not think of themselves as humans temporarily stationed on an alien world, waiting for the day they could return. They would think of themselves as Martians, their connection to Earth becoming something like nostalgia, reverence, or ancestor veneration, but not belonging. In this way, a new human identity would be born, not replacing Earth humanity, but running parallel to it, a separate branch of the human tree. The psychological literature on identity formation suggests something even more intricate happening at the level of culture and symbol. Humans everywhere create meaning through stories, through shared reference points, through the markers that say, "We are us." For Earth-born settlers on Mars, these might be memories of rain, of ocean horizons, of the smell of forests after summer storms. But for their children and grandchildren, the meaningful reference points would be Martian, the distinctive sound of Martian dust storms against habitat walls, the particular curve of Valles Marineris as seen from a high orbit, the names of the ancient impact craters their settlements cluster around, the Martian names they give their children, derived perhaps from linguistic roots that honor their heritage but sound new, unmoored from Earth's languages. A girl might be named Ariella, for Aries, but the name would come to mean something specific and Martian, untranslatable in its deepest sense to someone who has only known Earth. There is something almost wistful in imagining this. The children of Mars would grow up hearing stories of Earth the way children everywhere have heard stories of the old country, the ancestral lands, the homeland left behind. But unlike the migrant children of history, they would never be able to simply return, never be able to fully inhabit that world. They would be eternally of Mars, their biology and psychology permanently shaped by its conditions. Earth would become mythic in their cultural memory, a golden age, a lost paradise, a reminder of where their species came from. And yet there would be something other than melancholy in this. There would be pride and purpose. They would be the first generation of a genuinely new branch of humanity, shaped by a new world, living according to its rhythms and its logic. They would know themselves as Martians, in a way that no generation before them could ever quite manage. The psychological question of home is fundamentally a question of where one's body and mind are shaped. For Martian-born children, that shaping happened under a salmon sky, in low gravity, surrounded by the hum of habitat systems, breathing recycled air that carries the signature of human habitation, learning through experience that survival depends on collective cooperation, on the integrity of domes and airlocks, on the success of distant supply missions from Earth. These are not incidental details, they are the bedrock of identity, and they create a way of seeing the world that is distinctly Martian, more egalitarian perhaps, more focused on collective welfare, more attentive to the fragility of systems that keep humans alive. One might wonder whether children raised in such conditions would develop different values, different approaches to leadership, different assumptions about what it means to be human. The research on how environment shapes psychology, how culture is born from the demands and possibilities of place, suggests that they almost certainly would. There is also something profound happening at the level of imagination and aspiration. For Earth-born settlers, Mars represents achievement, the fulfillment of a dream that had haunted human consciousness for centuries. But for the Martian-born, Mars is not an achievement, it is simply the world they inhabit. Their dreams, their aspirations, their sense of what is possible would naturally orient toward what lies beyond their current horizon. Some might look toward the moons of Mars, Phobos and Deimos, distant and smaller and even more isolated than their home world. Some might look toward the asteroids, toward Venus, toward the outer planets. The psychological tendency to move outward, to explore, to seek what lies beyond the known, would not disappear simply because humans had reached Mars. It would express itself anew, in a new generation thinking of Mars as home the way we think of Earth, and casting their gaze toward the next frontier. The deep human impulse toward expansion and discovery would continue, but it would be rooted now in a perspective fundamentally alien to anything Earth dwellers knew. There exists, somewhere in the minds of scientists and dreamers alike, a possibility so distant and so profound that it feels less like science and more like mythology. It is the slow warming of Mars itself, not the gradual shifts we've already described, the greenhouse gases rising from early colonial industry, the incremental thickening of the air, but something far more ambitious, something that would take not decades or even centuries, but perhaps 1,000 years or more. And yet, it is worth imagining, because imagination itself is how we understand what might become possible. Picture, if you will, the poles of Mars as they are now. Brilliant white caps of frozen carbon dioxide and water ice, sitting atop a planet so cold that breath becomes crystalline in moments. For hundreds of years, the early Martian colonists have been tending their domes, their hidden chambers, their carefully managed worlds. But what if, in the depths of their future, their descendants decided to remake the planet itself? The first and most essential step would seem almost impossible: restoring Mars's magnetic field. You see, Mars once had one. Billions of years ago, the planet possessed a protective magnetosphere, an invisible shield generated by a molten iron core, much like Earth's. But Mars is smaller, and its core cooled. The magnetic field collapsed. Without it, the solar wind stripped away much of the atmosphere, leaving behind the thin, gasping wisps we know today. To terraform Mars, some scientists propose, you would need to restore this protection. One way to do this, and here the speculation deepens into genuine uncertainty, would be to place a massive artificial magnet at the Lagrange point between Mars and the Sun, a location in space where gravitational forces balance, allowing an object to sit relatively still between the two bodies. A magnetic shield of sufficient strength, positioned there, could deflect the solar wind as the planet's lost field once did. It would be one of the grandest engineering projects humanity has ever conceived, and it would take centuries to construct and maintain. But imagine the patience of a species spread across two planets. Imagine what they might accomplish. With that shield in place, something slow and quiet would begin to happen. The atmosphere itself would be safer. The solar wind would cease its relentless theft of atmospheric molecules. And this creates a window, an opening, for the next phase. Warming Mars. Thickening the air. Greenhouse gases, the very same compounds that trouble us here on Earth, would become tools of profound transformation. Industrial facilities in the Martian lowlands might begin, deliberately and carefully, to release perfluorocarbons and other heat-trapping gases into the thin Martian sky. At the same time, vast mirrors positioned in orbit could direct additional sunlight toward the polar regions, concentrating warmth on those frozen caps. Does this sound fantastical? Perhaps, but the physics is sound, the chemistry is understood. What is uncertain is only whether humanity would choose to do it, and whether we would have the patience to wait for results measured in centuries rather than years. As the decades pass into centuries, the white poles would begin to darken. The carbon dioxide ice would sublimate, transform from solid directly into gas, releasing that CO2 into the atmosphere, creating a stronger greenhouse effect. Water ice, exposed and warmed, would melt. The first liquid water to flow on the Martian surface in billions of years would trickle downward. Small streams at first, then larger ones. The atmospheric pressure would gradually increase. Slowly, so very slowly, the sky would become thicker, less transparent. The temperature would rise, degree by patient degree. And what would this mean? What would Mars become? After 500 years of such work, the planet would still be cold by Earth standards, but no longer utterly hostile to human life without protection. The atmospheric pressure at the lowest elevations might become breathable, though the air would still be thin, still require adjustment. The polar regions might nurture simple plants, genetically modified organisms that thrive in cold, in reduced pressure, in soil that has never known life. The ice would continue to flow downward from the poles like ancient glaciers. After 1,000 years, the transformation deepens. Oceans might begin to form in the lowlands, not vast planetary seas like Earth's, but significant bodies of liquid water, gathering in the great basin of Hellas Planitia, in the deep canyons, in the vast depression of Valles Marineris. The atmosphere would be thicker still, perhaps a third or a quarter of Earth's pressure. the color of the sky might shift from the butterscotch tan of today towards something closer to Earth's blue, as Rayleigh scattering of the thicker atmosphere bends light in new ways. Clouds might form, rain might fall. Picture this, 2,000 years from now, in the imagined future of a species patient beyond our current comprehension. The poles have warmed. The ice has diminished, though not vanished entirely. Great glaciers remain at the heights, but the lowlands are transformed. Small seas dot the planet's surface. The atmosphere has grown thick enough that humans, with simple oxygen masks, or eventually with no masks at all, could walk upon Mars without the rigid suits their ancestors required. Not in comfort. The gravity is still light. The air is still thin by Earth standards. The cold still bites. But breathing, walking, perhaps even someday, without technological aid. The sky is rose, not rust. The two small moons still trace their paths overhead. But now, when the sun sets on Mars, its light scatters through a thicker atmosphere, painting the horizon in gradations of pink and purple that Earth's sky has never known. The sun hangs lower, larger, casting longer shadows. The temperature hovers below freezing, but only barely in the warmest regions. In the daytime hours of summer, patches of primitive lichen cover the rocks. Engineered grasses grow in specially prepared soil. The first true Martian forests might have begun their slow spread, hardy species selected and reselected over countless generations, adapted to the remaining harshness. This is, of course, almost entirely speculative. We do not know if humanity will even survive the next few centuries, let alone maintain the commitment and resources for such a project across millennia. We do not know if future humans would choose to terraform Mars, or if they might prefer to keep it as a kind of preserve, a monument to the untouched cosmos. The technology itself, while not physically impossible, exists at the very edge of our current understanding. It would require energy sources we are only beginning to develop. It would demand a level of planetary engineering that seems almost godlike in its scope. And yet the possibility exists. The laws of physics do not forbid it. The chemistry works. The biology, adapted and modified, might flourish. It is a dream not of centuries but of deep time itself, a dream of patience, a dream of slow transformation, a dream that reminds us how vast the future might be, if we are clever enough and patient enough and committed enough to realize it. Millions of years ago, Earth was a world utterly hostile to human life. We evolved here, slowly, across eons. Mars, in this imagined future, becomes not the home of our inevitable colonization, but the proving ground of our deepest ambitions as a species. A new world not conquered but cultivated, not imported with life from Earth, but seeded with it, nurtured into viability by the hands and minds of our descendants, across timescales that dwarf human history itself. And yet, as the centuries accumulated on the rust-colored plains, as generation succeeded generation in their Martian homes, something profound would shift in humanity's understanding of itself. The question would no longer be whether we could survive on Mars. It would be, what does survival mean when you have two worlds? To have established a true, self-sustaining human civilization on Mars, one that would endure not for decades but for millennia, would be to have created something that had never existed before in our species' history. A second seed, a backup. Not in the cold, sterile sense of a data file copied to a distant server, but in the deepest biological and cultural sense. A second home where human consciousness could think, dream, argue, create, and persist, entirely independent of what happened on Earth. This resilience, this profound insurance against catastrophe, would reshape how humanity understood its own fragility. Here on Earth, we have always been singularly vulnerable, in a way we have perhaps not fully reckoned with. We are one planet, one thin layer of atmosphere, one magnetic field protecting us from the solar wind. Should a large enough asteroid strike, should a supervolcano awaken, should we fail catastrophically in stewarding our own climate and ecosystems, human civilization could falter, could end. The thought has haunted our species in recent centuries, expressed first through mythology, then through science. To have overcome that singular vulnerability, to have built a civilization that could survive the loss of Earth itself, would be to have reached a kind of maturity as a species that we have never before achieved. But this resilience would cut both ways, and the early Martian settlers would have understood this with the clarity that only isolation can bring. They would have known that Mars too was vulnerable, different vulnerabilities perhaps. The thin atmosphere could never be fully thickened in any human timescale. The magnetic field could never be fully restored. The gravity would always be a third of Earth's, shaping the bodies of those born there in ways that could never be reversed. Yet within those constraints, life, human life, had taken root, and that rootedness itself would become a form of strength. What would this mean, psychologically, for a species that had for so long understood itself as the children of one world? There would be something both comforting and vertiginous in the knowledge that humanity was no longer earthbound, that our fate was no longer yoked entirely to the health of one biosphere. The philosophers and poets among the early Martian generations would have felt this acutely, a loosening of the old anxieties, the sense that something precious and irreplaceable had been distributed across space, that there were now two living planets where human beings loved, built, mourned, and hoped. This would not eliminate Earth's problems, of course, nor would it mean that Mars would be safe from crisis. The two civilizations would remain connected through trade, knowledge, communication, even kinship. A child born on Mars might have grandparents on Earth. A discovery made in a Martian laboratory might save lives in Cairo or Sao Paulo. The two worlds would be bound together, not through dependence, but through the deeper ties of a common species, a shared ancestry. Yet, there would be a kind of independence too, a growing sense that humanity had cracked open the shell of a single-world existence. And with that independence would come a new kind of responsibility. The Martian settlements would have to be truly self-sufficient, not merely in food and water and oxygen, but in knowledge and culture and the ability to face crisis without looking homeward for salvation. To be, in some profound sense, a complete human world. The philosophers would debate what this meant for human identity itself. If you were born on Mars, raised under the rust-colored sky, never having set foot on Earth except in simulation or imagination, was Earth still your home? Did home mean the place where your parents came from, or the place where you first drew breath? Or was home something else entirely? Not a location, but a network of meaning, a set of relationships and values that could exist anywhere. Some scholars would argue that the existence of two human civilizations would eventually lead to the emergence of two distinct human cultures, as different from each other as Japanese culture is from Brazilian. Others would insist that the constant communication and occasional migration between worlds would keep them bound together as variations on a single human theme. Perhaps the truth would be more subtle, that the two worlds would be connected and separate simultaneously, like cells in a larger organism that could function independently yet remained part of a greater whole. The gravity itself would ensure a kind of separation that time and technology could not overcome. Children born on Mars could never easily return to Earth. The weight of a full Earth gravity would crush bones that had grown light and long under Martian skies. And Earth-born humans, if they tried to settle permanently on Mars after reaching adulthood, would face their own struggles, their bodies too heavy, too built for a world they could no longer comfortably inhabit. Migration between worlds would be a young person's journey, perhaps a one-way passage. You would leave Earth for Mars knowing, on some level, that you were leaving it forever, that your bones would reshape themselves in the Martian air, that you were becoming something new. This would be the deepest meaning of permanence on Mars. Not just the construction of buildings and the cultivation of crops, and the establishment of laws and governments, though those things would matter, but the slow biological and cultural divergence of humanity into two branches, two worlds, each one real and vital and irreplaceable, two centers of consciousness, two homes for what it means to be human. And perhaps, in the deep future that we can barely imagine, there might be others. Venus, rendered habitable through some unimaginable technology, the moons of Jupiter, floating in the darkness beyond. The faint possibility of interstellar travel, of spreading across not just our own solar system but beyond it, into the vast and mostly empty cosmos. None of this would be certain. Much of it would remain speculation, the dreams of people looking at stars. But the existence of a permanent human civilization on Mars would have cracked open the possibility in a way that could never be sealed shut again. For now, though, as we contemplate this future from our single, fragile, irreplaceable Earth, the image of a second living world remains almost incomprehensibly distant. Yet the seeds of it are already being laid. In the rovers that trundle across the Martian surface, in the laboratories where scientists work to understand how to grow food in alien soil, in the minds of children who look up at the red star in the night sky and wonder not whether they could go there, but whether they might someday belong there. And so we arrive at dusk on Mars, that long salmon-colored twilight that stretches across the horizon like a held breath. The sun, smaller than it appears from Earth, descends toward the jagged rim of a distant crater, casting the landscape in amber and shadow. The dust, that fine, ancient dust that has settled into every crevice and grain, catches the fading light and glows with a warmth that belies the frozen darkness soon to come. Up above, the stars are already visible, sharper and more vivid than they ever appear from Earth, because there is so little atmosphere to soften them, so little moisture to scatter their light. In the habitats scattered across this terrain, lights begin to flicker on, not the harsh fluorescence of early outposts, but something gentler now, something more considered, warm amber lamps, bioluminescent panels cultivated from terrestrial organisms, adapted and evolved. Through the transparent sections of the domes, you might see the silhouettes of people moving about, preparing evening meals in common spaces, checking telemetry on screens, tending to the gardens one final time before the soul turns toward night. The youngest among them, perhaps born here or arrived too young to remember Earth clearly, move through these routines with an ease that speaks of belonging. This is simply where they live. This is home. There is a hum beneath all of this activity. A deep, constant hum, the pulse of life support systems, the whisper of recycled air moving through ventilation shafts, the gentle thrum of power generation systems drawing energy from solar panels or nuclear reactors buried safely beneath the regolith. It is the sound of human civilization in miniature, a symphony of engineering and intention playing out against the Martian silence. When you listen closely, really listen, you hear something almost musical in it, the breath of a world learning to live. What does it feel like to stand at the threshold between two identities? On Mars, that question becomes something each settler must carry within themselves. They are still tethered to Earth by memory, by ancestry, by genetic inheritance. And yet something in them is beginning to shift. The lighter gravity has changed their body's muscle density, their posture, the way they move through space. Their children, if they have them, will grow taller here, their skeletons less dense, their lungs adapted to the thin air. In a few generations, what will it mean to return to Earth? What will it mean to choose not to? The pink light deepens toward violet. Phobos rises, that small, lumpy moon, moving so quickly that it races across the sky, rising and setting multiple times in a single Martian night. Deimos follows, more distant, more stately, a pale sentinel. Two moons casting their gentle glow across a world that humans have decided to stay on. Permanently, not as visitors, not as explorers gathering data to bring home, but as residents, as inhabitants, as the first generation of a species that is learning to live somewhere other than the world it was born to. There is something profoundly humble in this image. Here we are, a species that arose on one small planet, cradled by a particular gravity, nourished by a particular chemistry, evolved to breathe a particular air, and yet we have looked at another world, harsh, cold, ancient, austere, and said, we can learn to live there too. We can adapt, we can build, we can make it home. It is not certainty that drives this. It is something deeper, a refusal to accept limitation, a faith in human ingenuity and resilience that borders on the irrational and yet has carried us through every threshold before. In centuries, perhaps in millennia, Mars will be different. The atmosphere will be thicker, warmed by greenhouse gases released intentionally by human hands or by the simple accident of our presence. Water will flow in stream beds that have been dry for billions of years. Lichens and hardy grasses might cling to open rock. The sky might darken towards something closer to blue. Forests might grow in protected valleys, fed by rain that falls from clouds thick with moisture, or perhaps that remains forever in the realm of dream. Perhaps Mars will retain its austere beauty, its rust-red truth, and humans will simply learn to live within those constraints, building their cities and their cultures in the image of the world they inhabit, rather than trying to remake it in the image of Earth. Either way, something will have changed at the level of human consciousness. We will no longer be a single-planet species. We will have proven, not in theory, but in flesh and blood, and in the daily lives of mothers and children and engineers and artists, that we can adapt to the truly alien and call it home. That is not a small thing. That is, perhaps, the most profound shift in identity that any species can undergo. The dusk deepens. The temperature drops rapidly, as it always does on Mars when the sun surrenders. The thermal systems in the habitats hum a little louder, maintaining the warmth. Somewhere, someone is singing. Somewhere else, someone is reading a story to a child about Earth, about rain, about oceans they have only seen in images. Someone is writing. Someone is sleeping, their dreams perhaps carrying them between two worlds, two gravities, two identities. Someone is gazing out through a transparent panel at the settling darkness and wondering what it will mean to die here, to have lived one's entire life under these stars, to have no memory of anywhere else. The red world settles into darkness. The hum continues. The lights in the habitats glow steadily against the black. And in that small, determined luminescence against the vast Martian night, we see something that humans have done again and again. We have made a place for ourselves where no place was made for us. We have looked at a world that asks nothing of us, that offers no welcome, and we have said, we will stay. We will build, we will dream here. We will call this ours. It is a quiet victory, played out in the ordinary routines of ordinary people doing extraordinary things, surviving, adapting, growing, falling in love, raising children, creating meaning in the face of silence and cold and distance. In the slow fade of one Martian dusk into another, in the accumulation of souls into years and years into generations, the question that once seemed so theoretical, so distant, becomes something else entirely. It becomes real. It becomes lived. It becomes, simply, the answer to what it means to be human somewhere other than the world we came from. And as your own thoughts drift and settle, as the boundaries between imagination and rest begin to blur, Remember that somewhere in the possible futures branching out from this moment, that red dust world is humming with a purpose that began right here, in the gentle act of contemplating what might be and deciding to make it so.